3.2, exploring the Pythagorean relationship. Working example 1 is describing relationships in right triangles. So we're going to start with a definition, and this is really, really important when dealing with Pythagorean theorem. A right triangle is a very specific type of triangle. It is a triangle that has a right angle in it, and a right angle is a 90-degree angle. The right angle is marked with a small square. So in this triangle here, we have a little tiny square on the inside, and that shows you that that angle is 90 degrees. It is a square angle or a right angle. Now, the two shorter sides of the triangle, so the two sides that actually connect up with that right angle, are called legs. So yes, triangles have legs. They're not going to walk away, but they have legs. The longest side, so the side that does not touch this 90-degree angle, is called the hypotenuse. So you should probably write that on a piece of paper like 100 times so that you figure out the spelling, but it's called the hypotenuse. So, here is an example of where the Pythagorean theorem comes from. We've got a right angle triangle, and then each side of that triangle is making a square. So we've got three different size squares. And actually this is a very special one, with this length being 3 centimeters and this leg being 4 centimeters and the hypotenuse being 5. That relationship with the 3, 4, and 5 is a very special one when it comes to Pythagorean theorem, but we'll get to that later. So, what is the area of each square? Well, if this square is 5 centimeters on this side, it's 5 centimeters on this side. So it is 5 squared. So area is equal to side squared, or side times side. So in this case, it's 5 times 5, which is equal to 25 centimeters squared. This little guy over here has a side length of 3, so its area is 3 times 3, or 9 centimeters squared. And if you want to write the 3 times 3, that's fine. And then this one, it's 4 by 4. So 4 by 4 is equal to 16 centimeters squared. So we've got 9 centimeters squared, 16 centimeters squared, and 25 centimeters squared. Now, which side is the hypotenuse of the triangle? If you've got a triangle, you can label it sides using letters. And in this case, A, B, and C are very commonly used for labeling the sides of a triangle. The legs, so the sides that touch the 90-degree angle, are labeled A and B. The hypotenuse is labeled C. So side C is the hypotenuse. It is opposite the right, and I'll put 90-degree angle. So A and B are the legs that touch the 90-degree angle. C is the hypotenuse. Now, if we write an addition statement to show the relationship between the areas of these three squares, we've got 9 centimeters for this one, 9 centimeters squared. This one is 16 centimeters squared. This one is 25 centimeters squared. 9, 16, and 25 have a special relationship. If you add 9 and 16 together, you will get 25. 9 plus 16 gives you 25. So there's a very special relationship there, and that is actually where the Pythagorean theorem comes from. So, if you write that relationship, you can say that 9 centimeters squared plus 16 centimeters squared is equal to 25 centimeters squared. Based on this triangle. Now if that's the case, and we labeled our triangle this way, A, B, and C, this 9 represents A squared, where A is the length of the leg. The 16 represents B squared, or the length of the B leg, and that is equal to C squared, the length of the hypotenuse. And as it turns out, this equation here is in fact our Pythagorean theorem. That's something that you're going to work with for the rest of this unit. So, describe the relationship between the side lengths of the triangle. Use words and symbols. Okay. Well, I've used symbols up above, but if you want to use words, the sum of the square of each side length is equal to the square of the length of the hypotenuse. Now I'm spelling it wrong. No, hypotenuse. So the sum of the square of each side length. So so the sum of the side lengths, so 3 squared plus 4 squared, is equal to the square of the length of the hypotenuse, so it's equal to 5 squared. And that's a description of your Pythagorean theorem. Just give you a moment to finish writing that up. We're actually going to move on because we're coming up to a show you know. So the Pythagorean relationship is the relationship between the lengths of the sides of the triangle. A squared plus B squared equals C squared, where C is the hypotenuse. So that's just restating what I've already covered. So next up is a show you know. Please go ahead and do that.